Welcome to the Crazy Hat Chemist. So another video in intermolecular forces. So let's get moving. Bam! So today we're talking about intermolecular forces in induced. And these are called London Dispersion Forces, or LDF. London Dispersion Forces. So let's get moving on this. Iodine is a non-polar molecule. However, because iodine has a rather large electron cloud, that is, it has a very large mass and a large number of electrons, consequently, iodine can spontaneously and temporarily self-polarize. Okay, and forming a charge separation within the molecule, i.e., it has a temporary dipole. Okay, as a self-polarized iodine molecule approaches another iodine molecule that is non-self-polarized, the polarized molecule will induce or force a non-polarized molecule to be polarized. This in turn will induce other subsequent iodine molecules to be polarized. Iodine is a solid at room temperature and pressure because of its large molar mass and the ability of iodine to self-polarize and induce a dipole in adjacent molecules. Very important, right? Because it is a halogen, and iodine is the solid of all of the halogens. Bromine is a liquid, and chlorine and fluorine are both gases at room temperature and pressure. So here's a diagrammatic view of what I've just described. Here's an iodine molecule. Right here, it is spherical in shape, okay? And then, all of a sudden, it self-polarizes. Why does this happen? It just happens just randomly. Why? Because iodine has a large number of electrons, a large electron cloud, and it can self-polarize. That means it has one end that has a partial positive, and one end that has a partial negative into it. That's that self-polarization. Okay? This is a temporary one. And so now we have this molecule that is self-polarized, and it will interact with a non-polarized iodine molecule. And this polarized molecule will interact with that non-polarized molecule and induce a dipole in that second one. And therefore, these two will have a intermolecular force that is an induced intermolecular force, and this is called a London dispersion force. Okay, there's a picture of iodine here that I have in the lab. It's solid iodine, and if you were to take a close look at this here really carefully, iodine is super cool because it sublimates. It goes from the solid state to the gaseous state, bypassing the liquid state completely, just like carbon dioxide dry ice does. So in this bottle here, I have solid iodine. It's on its side. And then taped on the back, on the outside of the bottle, is a piece of white paper. And you can see kind of a purplish hue inside this glass container. And that is gaseous iodine. If you hold on to this bottle and warm it up, you'll see more of that purple color being produced because it sublimates, going from that solid state directly into that gaseous state. Okay, bypassing the liquid state. Dry ice does the same thing. All right, that is another Crazy Hat video by the Crazy Hat Chemist, and of course I got a crazy hat. Give me a thumbs up, subscribe to my YouTube channel, and pass this on to all your cool chemistry friends, or at least all your people that do need, all your friends that do need help in chemistry, because this is the place to come. Bye now.